The plasma physicist David Lapointe suggests that there is much more to the primal fields dynamics than what meets the eye. He suggests that our Sun operates within a sphere of highly concentrated plasma that is generated by powerful magnetic fields, which he calls the primal fields, and that the plasma sphere around the Sun is magnetically confined by these fields. If this was not so, our Sun would be but a dim speck in the sky, without the large magnetic fields acting on it that surround it with a sphere of concentrated plasma. The Earth would be a cold planet then, extensively covered with ice as it once was 700 million years ago. But is David Lapointe correct? Do the primal fields really exist outside the laboratory environment? Can they be seen? And if they do exist and are visible, is it possible for these vital fields to collapse? So let's explore what stands behind it all. The key component of the primal fields theory is the existence of one or two bowl-shaped electromagnetic fields. David Lapointe uses two bowl-shaped magnets of opposite magnetic polarity for his experiments conducted in a vacuum chamber. In the environment of space, however, no bowl-shaped magnets hang in the sky. For the required magnetic fields to exist, they must be generated by the natural phenomenon of electricity flowing in plasma in space. And this is exactly what happens. The term plasma refers to electrically charged particles that exist in free-flowing form in space, primarily as protons and electrons, the stuff that atoms become made of when they are bound together. In space, they are free-flowing. However, flowing electricity creates magnetic fields, and by these fields, the flowing electricity becomes pinched together. When electricity is carried by two parallel wires, with the current flowing in the same direction, the wires are attracted to each other by what is called the Lorentz force. The same happens in plasma in space, where electricity is flowing freely, without wires. There, the effect is called the zeta pinch effect. In space, the flowing electric plasma particles are drawn to each other by the same magnetic forces that attract wires to each other. However, while the wires remain physically fixed, plasma currents in space become compressed thereby into ever smaller magnetic confinement. By the confinement, the current density is increased, which in turn pinches the plasma currents still tighter and tighter together, forming a bowl-shaped magnetic field in the process at the very end of the pinched plasma stream. But something happens in the bowl when the plasma currents exceed a critical limit. As they converge to ever tighter confinement, the currents and the resulting magnetic fields become unstable by the pinch effects. Past a critical point, the currents become twisted into complex knots, whereby the bowl-shaped magnetic field that forms opens up at the center. There, below the opening, an electromagnetically confined high-density plasma stream is formed by a number of interacting effects. On the platform of the primal fields, the entire structure that we see, that extends across 50 kilometers from top to bottom forms in a fraction of a second. Typically, the sprite remains active for about a single second until the plasma flow becomes too weak to maintain the primal fields. At the point when the primal fields collapse, the entire structure simply vanishes. In comparing the sprite with the larger scale of the solar system, the sprite's 1 second active time is comparable to the solar system's interglacial period of the sun's active time of roughly 12,000 years. The on-off process is the same in both cases, though different in scale. Let me illustrate now how the process functions that forms the primal fields. This is best illustrated by looking at another lab experiment that is carried out with an instrument called the dense plasma focus device. The device is made up of a ring of electrodes that surrounds a hollow electrode at the center. When an electric field is applied, a plasma sheet forms. The plasma sheet is instantly drawn towards the opening of the central electrode and is then drawn into it. By it being drawn into the opening, the plasma becomes extremely pinched together. There, it becomes unstable and begins to twist. At first, the plasma twists itself into a spiral. Then the spiral becomes compacted. The more it becomes compacted, the more unstable the spiral becomes and becomes twisted. Eventually, the twisting forms a complex knot. The illustrations are snapshots taken from a video about the dense plasma focus device. In space, the plasma instabilities that form the complex knots open the magnetic poles that form at the end of the concentrated plasma currents. As the process unfolds further, a high-density plasma concentration forms outside the magnetic poles. That's where the sun is located in a solar system and is powered thereby. When, however, the plasma streams are too weak to cause an extreme pinch effect to happen, the plasma streams simply flow through the solar system without affecting anything. The sun thereby remains dim and not actively powered. When the sun is powered by a dense plasma sphere surrounding it, the flow-through process still happens. The plasma flows out of the plasma sphere since the sun utilizes only a small portion of it. In the outflow, another magnetic field is generated, but with the opposite polarity. The evidence suggests that all large electromagnetic structures that exist in space, when they are drawn to a sun or, on a larger scale, to a galaxy, whereby the primal fields form, exist typically as complementary pairs. Between the two gigantic complementary electromagnetic poles, a number of interesting effects come to light with interesting principles that are critical for the overall dynamic interactions. The magnetic fields are the strongest at the focal point of the two bowl-shaped magnetic structures. In the narrow space between the two complementary structures lies typically a solar system with a sun or several suns. On the central axis, and with planets orbiting on a thin ecliptic plane in the space between the two electromagnetic pole-type fields. While the two pole-type electromagnetic fields are each separate entities, they work together functionally as a whole. Their function is to concentrate the plasma flow that pervades all space and focus that onto the tightly confined sphere in which our Sun is located and is powered by it. The remarkable concentration is accomplished in the laboratory by a set of two pole-type structures shown in red and blue, facing one another with opposite complementary polarities. The small point in the middle between the two magnetic pole structures is where a polarity flip point is located. The flip point appears to be responsible for flipping the polarity of the Sun's magnetic field with every solar cycle. The location of the flip point moves slightly when one of the two pole structures becomes weaker than the other. This effect causes the polarity of the magnetic field of the Sun to assume the dominant polarity and thus flip with the 11-year solar cycles that are simply resonance cycles between the complementary magnetic structures. The plasma concentration that is required for the Sun to function is dynamically produced in the illustrated structure by the interaction of its three functional magnetic elements that are structured around the respective hole in the magnetic poles. Each of these three structures has a specific function to fulfill. The flip ring flips the orientation of plasma. It flips it under the magnetic confinement dome, while the choke ring below helps to keep it there. The plasma particles that flow into the big red bowl are flipped upwards as they pass the flip ring shown in yellow. They are collected together there into a massive accumulation. The plasma particles become concentrated by this process. The concentration creates a high-pressure environment. The magnetic choke ring within the opening of the magnetic bowl focuses the escaping plasma flow into a tightly concentrated stream beneath the hole. In some lab experiments, the focused stream expands into a sphere. When plasma is drawn out of the sphere in the flow-through process, a complementary bowl structure is formed with opposite orientation and opposite magnetic polarity. In this structure, the outflowing stream of lesser density is drawn into the bowls, where they expand in the reverse process, reverting back to the normal density of the prevailing plasma stream. The process that is illustrated here can be verified with laboratory experiments. In a high-powered plasma experiment of the type that is conducted at the Los Alamos National Laboratory, the complementary bowl structures that the plasma currents by their own interaction is clearly visible. Also, the containment dome that forms inside the bowl is visible in the experiment that is illustrated here. In this particular experiment, the magnetically focused plasma stream that flows between the bowls did not form a sphere for which a catalyst would be required, but it did form a distinct plasma ring around the focused stream centered between the bolts. Evidence exists that the lab-created shape of plasma formed by the primal fields was visible in ancient time in the sky. Archetypal drawings collected from widely separated regions on Earth show a remarkable similarity of their design with the lab-created plasma formations. The similarity suggests that the complementary plasma bowl shapes were common occurrences at one time, appearing and disappearing in the skies like so many UFO sightings today, or like the sprites that still do under special conditions. David LaPointe also discovers two more features of the primal fields for which widely known evidence exists, which are the plasma jets and the magnetic flip point. He discovered that when plasma pressure under the confinement dome becomes too great, the dome will rupture at its weakest point, by which excess plasma escapes in a burst until the rift closes up again under the resulting lower pressure. By this plasma venting process, the magnetic strength of the respective bowl structure weakens somewhat. The resulting imbalance shifts the convergence of the magnetic fields, and with it, it shifts a magnetic flip point that David LaPointe also discovered forms below the opening of the magnetic poles. In the case of the solar system, the resulting imbalance, which shifts the flip point, flips the sun's magnetic field at the high point of the 11-year solar cycles, that are thereby recognized to be simply resonance cycles that oscillate between the two complementary electromagnetic structures of the solar system. What the complete primal fields system that powers our solar system and the sun may look like in practice can be seen illustrated in the operation of the Red Square Nebula that can serve as a model for this purpose. In this model, we see all the essential features of the primal field system clearly visible. We see the two complementary bowl-type structures in operation. One concentrates the galactic plasma streams like a funnel. In the funnel, we can see the flip ring, and below it, the choke ring, below which a cone of concentrated plasma extends that focus onto a sun, or onto a number of them. And we see the reverse happening for the outgoing plasma stream. We can see all the essential features reflected here that have been observed in laboratory plasma flow experiments. Our galaxy, when it is observed as a whole, also operates on essentially the same dynamic platform, though on a vastly larger scale than a solar system. But there too, we see unmistakable evidence of two complementary electromagnetic bowls that form highly condensed plasma concentrations under their respective confinement domes. The concentration is visible in X-ray and gamma-ray emissions. We can also see the extremely concentrated plasma sphere below the confinement dome and between the two bowl structures that are indicated by the existence of the confinement domes. The concentrated plasma sphere is also the center of the galaxy. Large intergalactic plasma streams feed in and out of the primal fields that form the confinement domes. These two long intergalactic connecting streams, one incoming and one outgoing, both have very long resonance cycles. These very long electric resonance cycles that correspond to the long distances between the galaxies evidently affect the strength of the primal fields that power the galaxy and are thereby the cause for the two long climate cycles that have been observed on Earth. These very long electric resonance cycles, the 62 million year cycle and the 140 million year cycle, show up as long climate cycles that have been preserved in sediment records that enable us to look back in time more than 500 million years. Presently, the two very long climate cycles are both near their minimum point, whereby weak plasma conditions have been created that have gripped the Earth for the last 2 million years, in which the ice ages happened. During these weak conditions that have been slowly developing for the last 5 million years, which are getting still weaker, the breakdown of the primal fields that power our solar system has become a regular occurrence during the weakest times. Then, when the plasma streams that flow through the solar system become so weak that they drop below a threshold, a point is reached when the pinch effect in the plasma streams is no longer strong enough to twist the plasma currents into knots to create the bowl-type magnetic structures with the void at the center that make up the primal fields. And so the primal fields cannot form. Then what once existed suddenly exists no more. The plasma currents become no longer concentrated then, but simply flow through the solar system without becoming focused around the sun. At this point, the sun simply turns off. It becomes inactive, dim and cold. That's when the Ice Age begins. The Ice Ages didn't last as long in the earlier phase of the weakening conditions. They lasted only 41,000 years then. As the general weakening continued, the 100,000-year-long Ice Ages began. This became named the Pleistocene Epoch. Throughout the Ice Ages, in which the primal fields fail, the sun becomes inactive for long periods. It becomes a dim yellow star that glows mostly by its stored-up energy in whatever nuclear decay may be going on within it. However, evidence exists that the sun remains not totally shut down during the long Ice Age glaciation periods, which typically lasts 100,000 years. The Earth would turn into a snowball if the sun would remain inactive for 100,000 years. Fortunately, this doesn't happen. Periodically, short pulses of high-density conditions do occur during the Ice Ages, which reinvigorate the plasma streams that enable the primal fields to form anew, whereby the sun becomes powered again. Unfortunately, these pulses are short in duration. The sun remains powered by these pulses for only a few decades, and then turns off again. Evidence exists that these pulses occurred on a fairly regular basis. Their occurrence has created large climate oscillations. Evidence has also been detected in ice core samples drilled from the Greenland ice sheet that these short periods when the sun becomes active again have occurred in intervals of 1470 years. The resulting oscillations have been named the Dansgaard-Oeschger oscillations.